This lecture is on solution stoichiometry. Remember, stoichiometry is the quantitative study of the relative amounts of reactants and products in chemical reactions. Solution stoichiometry involves chemical reactions that either consumes or produces aqueous solutions. Things to be looking for in performing these problems: 1 molar mass, 2 molarity, 3 density, 4 mole ratio or volume ratio. Problem 1 is, how many grams of Al are required to react with 35.0 ml of 2 molar HCl? The reaction is 6 HCl plus 2 Als forms 2 AlCl3 plus 3 H2. It is given that the volume of HCl is 35 milliliters and the molarity of HCl is 2 molar. One needs the mole ratio between HCl and Al, which is 2 moles of Al per 6 moles of HCl. And the molar mass of Al is 26.98 grams per mole of Al. The solution map begins with the volume of HCl and converted to moles of HCl after multiplying by its molarity. Next, the moles of HCl obtained converts to moles of Al by multiplying the mole ratio mentioned above. Lastly, the moles of Al convert to the grams of Al by multiplying the molar mass of Al. After plugging in all the values, the mass of Al is 0.630 G. Problem 2 is, how many liters of a 0.750 m solution of CaNO3 will be required to react with 148 G of Na2CO3? The reaction is CaNO3 plus 2 Na2CO3 forms CaCO3 plus 2 NaNO3. It is given that the mass of Na2CO3 is 148 grams. The molarity of CaNO3 is 0.750 molar. One needs the mole ratio between Na2CO3 and CaNO3 which is 1 mole of CaNO3 per 1 mole of Na2CO3, and the mole mass of Na2CO3 is 105.98 grams per mole of Na2CO3. The solution map begins with the mass of Na2CO3, and after dividing by the molar mass, obtains the moles of Na2CO3. Next, the moles of Na2CO3 is multiplied by the mole ratio above to obtain the moles of CaNO3 Lastly, the moles obtained is then divided by its molarity, resulting in getting the volume of CaNO3 After plugging in all the values, the volume is 1.86 L. Problem 3 is, how many milliliters of a 0.150 m PbNO3 are required to react with 75 ml of 0.200 NaI? The reaction is PbNO3 plus 2 NaI forms PbI2 plus 2 NaNO3. The given information is that the molarity of PbNO3 is 0.150 molar. In addition, the volume and molarity of NaI are 75 milliliters and 0.200 molar. One needs the mole ratio between NaI and PbNO3 which is 1 mole PbNO3 to 2 mole of NaI. The solution map starts with the volume of NaI, and after multiplying by its molarity, obtains the moles of NaI. Next, the moles of NaI is multiplied by the mole ratio above to obtain the moles of PbNO3 Lastly, if one divides by the molarity, the result will be the volume of PbNO3 parentheses 2. After plugging in all the values, the volume is 50 ml. Problem 4 is to find the molarity of sulfuric acid, H2SO4, is titrated with 0.750 m KOH. It requires 328.4 ml of KOH to neutralize a 40 milliliter sample of sulfuric acid. Calculate the concentration of the sulfuric acid. The reaction is H2SO4 plus 2 KOH forms K2SO4 plus 2 H2O. The given information is that the volume of KOH is 328.4 ml and its molarity is 0.750 molar. The volume of H2SO4 is 40 ml. One needs the mole ratio between KOH and H2SO4, which is 2 moles of KOH per 1 mole of H2SO4. The solution map starts with the volume of KOH, and after multiplying the molarity of KOH, obtains the moles of KOH. Next, multiply the mole ratio between H2SO4 and KOH to get moles of H2SO4. Lastly, take the moles of H2SO4 and divide by the volume of H2SO4 to obtain the molarity of H2SO4. After plugging in all of the values, the molarity is 3.08 molar. Here are some review exercises for you to work on. Solve each of the following problems. A volume of 25 ml of HL3 is titrated with 0.125 m NaOH. To completely neutralize the acid, 21.5 ml of NaOH must be added. Find the concentration of the nitric acid. The reaction is HNO3 plus NaOH forms NaNO3 plus H2O. B, tartaric acid, H2C4H4O6, is neutralized with 0.100 m NaOH. A sample of 3 grams of tartaric acid reacts with 45.0 milliliters of base. How concentrated is the base? The reaction is H2C4H4O6 plus 2 NaOH forms Na2C4H4O6 plus 2 H2O. C. How many grams of solid BaSO4 will form when Na2SO4 reacts with 25.0 ml of 0.500 m BaNO3 parentheses 2? The reaction is BaNO3 parentheses 2 plus Na2SO4 or BaSO4 plus 2 NaNO3. For the remaining part of this lecture are solutions to review exercises or problems. Please view only after completing these exercises.